So we're going to look at this function. And if I cover up this part that says limit, you've done this before. Limits are just algebra problems that say limit in front of them. It's a rational function. Do you remember all the asymptotes and things like that? Poles and all of that? We covered it back in Unit 4 this year. Okay. When it says limit as x goes to 2, that's what that means. Limit as x approach, or I'm sorry, it's not 2, it's -2. Limit as x approaches -2. We're looking at the behavior of the graph around -2. And so what I'm going to do is type this in the calculator, and we're going to look at the table, and we're going to look at what happens to both sides as we get closer and closer to -2. And all I really need for you to do is watch. I'm going to type it up here. So I'm going to go to y equals, and I'm going to type this in. So all you need to do is watch. I'm going to type it for you. Ooh, whoops. I've done this in years past where I have everybody get a calculator and then everybody types it in, but it takes forever to get everybody on the same page. So I've learned it's better if you guys just watch me. All right, do you see how I typed it in? Y equals? Okay. Now your table is right here, but I'm going to go to table set, second window. I want to start it at -2 because that's like the number that we're sort of zooming in on. And then this is what you're counting by, and I'm going to count by 0.5. So I'm going to count by halves. So I can set up my table. That's table set. Now I'm going to go to the table. So what I want you to first notice is, what does it say is going on at -2? Error. So let's put that in our table. And we'll talk about that. That's what the conversation is going to be. All right. So there's an error there. Now, I designed it to give me the 0.5 ones. So that's the ones on either end of the table. So we want to go to -2.5. What's our value for -2.5? Do you see them? All right, -1.4. And then for -1.5, do you see that one? -0.714. I didn't fit that in there very well. I wrote a little bit big. -0.714. All right, I'm going to go back to my table set. I'm going to start it back at -2 because that's the value we're centering on. What do I want to change what I'm counting by so I can get the next, we're like zooming in. Did you ever do an experiment in science class with a microscope? Do you guys still use those? And you like zoom in on like your little organism that you're looking at? That's what we're doing with a math problem, okay? What do I need to change it to so that I get these two values as we zoom in? 0.1, very good. All right, so I'm going to change it to 0.1, go back to my table. Here we go, I'll hold it up for you. -2.1, go ahead and write that number down, -1.069. And then for -1.9, it is -0.935. All right, so we got those two. I'm going to do one more time. We're going to go back to table set. I'm going to start it back at -2. What do I want to count by now? 0.01. Do you see how we're zooming in and closer, making that change even smaller? All right, so I'm going to go back to the table, and here they are. -2.01. We got -1.007. And then on the other side, -0.993. Here's the whole point, and this is what I need for you guys to get. As we zoom in on both sides, what are these numbers getting closer and closer and closer to? Well, no, there's an error, but what are these numbers getting closer and closer? -1.007 and -0.993. They're getting closer and closer to -1. That is what we are zooming in on both sides. Listen, this is the analogy I always use, and it usually goes well. Have you ever been walking up the stairs and you're not paying attention? And so when you get to the top, you accidentally take another step anyway, and you drop all your things and all your friends laugh at you? Do you know what I'm talking about? Okay. That's like what a limit is. It doesn't matter that there's not actually a step there. If there was, your foot would have landed right on it, because it's the behavior of where you're headed. Do you get what I'm saying? It is the behavior of where you're headed, not whether there's actually something there. It's just where you're going. Now, let me cover up this limit and we'll do this problem the way that we did in algebra class. What would you need to do to the numerator and the denominator here? If even by instinct, let your instinct kick in. You would factor it. All right, draw your two parentheses. I know factoring is a little tougher for you guys, but we'll get through it together. I made these both fairly easy ones to factor. X squared would be x times x. How would you split up 2? 2 and 1. Good. I don't do the symbols until the very end. I do like one thing at a time. I get the numbers first, then worry about the symbols. Now, what symbols would you need to get a positive 1x in the middle? Good. Plus 2 minus 1. Perfect. Now we're going to do the exact same thing in the denominator. How would you split up 10? Yeah, 5 and 2. And what symbols would you need to get a positive 7? Both are plus. Oh my gosh, what do you guys notice happen? They cancel out. Try to remember back to unit 4. What happens? I think I heard somebody say it already. When something cancels out, there's a hole. Now, because x plus 2 is what cancels out, the hole is -2 comma something. And how do you get the something? Well, you take -2 and plug it back in. Watch what happens. If you plug in -2, -2 minus 1 would be -3. -2 plus 5 is 3. And then if you reduce that, oh my gosh, it came out to -1. Now, does it matter that there's a hole? No, because it's the behavior of where you're headed. Okay. Now I have to get through a little bit of vocabulary to explain this to you, but then once we get down to do the problems, it'll actually go pretty quick. In order for a limit to exist, there's 3 things. First, the same value is approached from both sides. If the left side approaches 3 and the right side approaches 4, then the limit does not exist. The behavior has to be the same. Do you get what I'm saying? As you zoom in, it has to come to the same point. This gets older and older every year, but have you guys seen the movie Mean Girls? I always bring that up. Do you know at the end when she goes to that math competition and she's like, the limit does not exist, as though it only just occurred to her? It's funny because if you understand the math that she's doing, it's hilarious that was like, it should be like, duh. Do you know what I'm saying? Like, she's like, oh my gosh, the limit does not exist. Anyway, it's funny if you actually understand the math. So the same values approached from both sides. The graph does not oscillate. The word oscillate means it jumps back and forth. It's like up, down, up, down, up, down, up, down. I'm going to show you an example. Let me just type one in the calculator really quick. The example I always show everybody is sine of 1 over x. And again, I want you to just watch. Oh, you know what? Let me make sure I'm in radian mode. That would be important. And I'm going to put my zoom back to normal. So I want you to watch what happens with this graph at 0. Do you see how it looks like a little heartbeat machine? I'm going to zoom in on 0 a couple of times just so you can see what happens. We're going to like zoom in like a microscope and get closer and closer. Do you see what happened there? Let me zoom in again. Like it completely freaks out. Okay. If you zoom in far enough, it'll actually just look like a barcode. There's no overall behavior at 0. So we would say the limit does not exist. That's what's called oscillating behavior. Okay. And then lastly, the third thing, the graph does not increase or decrease without bound. Without bound, well, actually, before I say what it means, what do you think without bound means? Like without like a constraint, like it's going to go forever. Now, the one exception for that is except one-sided. You can get infinity or negative infinity as an answer as long as it's one-sided. The reason you can't for both sided, even if both sides go up to infinity, they're never gonna like touch or meet. So you can only get infinity or negative infinity if it's one-sided. Okay, that's all the like explanation we had to go through. The rest of this is gonna go real quick, and you're gonna have to look, because I don't have better explanations than look at the graph, there it is. That's the explanations for this. There's no problem to work out. There are no steps. You just look at it and state the answer, but you're gonna have to look, okay? So we're gonna use this lovely graph. You know what, let me try to zoom in a little bit more here. All right, so limit as x goes to -1. I need for you guys to watch. Here's -1. Do you all see that? If I were to zoom in on -1, is the same value approached from both sides? What value is that? At -1, what are we getting closer and closer to? 0 is the answer. That's literally all you do. Now let's try it again. I didn't write 0 on that line very well, did I? I'm going to need to fix. That's going to bother me. All right, now we're going to do this one. It says limit as x approaches 1. You're going to have to watch. Here's 1. There's a hole there. Remember, that doesn't matter. It's like falling up the steps. Is the same value approached from both sides? If you were to zoom in really, really far on 1, is it the same value from both sides? Yes. And what value is being approached? I know it's not actually there. -1 is your answer. Now look at this one. We're approaching -6, but do you see the little plus there? Oh, thank you. Do you remember how I introduced that to you a while ago when we did logarithms? And I was like, okay, foreshadowing. All right, so we're going to go to -6, but only from the right. So here, look, here's -6. Let me cover this up. We're only coming at it from the right. Where is that arrow pointing? Down. So we're going to put -infinity. You're allowed to put a positive or negative infinity as long as it's one-sided. Now this one says -6 from the left. All right, so look, -6 from the left. Where's the arrow pointing? Down. Good, -infinity. Now, here's where you have to understand what I've said to you so far. Do you see how this one says -6 and it's not sided? It's just overall. So when you look at -6, people will be like, well, the left side goes down and the right side goes down. I get you. But are these two arrows ever going to touch? No, so it's still a does not exist because they're never going to like converge at anything. So you can only put positive or negative infinity if it's one-sided. All right, this one is going to -2 from the left. So everybody look, here's -2. We want to come at it from the left. You have to watch me point to it because I don't have a better reason than here, look. So here's -2. Does it matter that there's a hole? No, it's like falling up the stairs. If we zoom in on -2 going from the left, what value is being approached? -1 is your answer. It doesn't matter that it's not actually there. It's what are you getting closer and closer to? Now this one's -2 from the right. So look, here's -2, but we're going at it from the right side. What value is being approached there? Can we say 2? I know it's off a little bit, but can we call that 2? Just for the sake of simplicity. If you want to be a purist and put like 2.3 or something, I guess you can. Now look, hey guys, I'm glad I woke you up and you're all talking, but can we focus? This one says -2 overall. If you go to -2 from the left and -2 from the right, do you see how they're not going to the same place? So we would say DNE does not exist. That's what's called a jump discontinuity because the graph, we talked about jump discontinuities, didn't we? Back in piecewise functions, jump discontinuity. See, I taught you a lot of this already. All right, this one. Limit as x goes, it's just more practice problems. Look at limit as x goes to -infinity. Watch me point to it. That's the left side of the graph. Where is this leveling off? Will it ever actually touch 0? No. But it's a limit. It doesn't matter if it's actually there. And that's end behavior. Limit as x goes to +infinity. That's just your end behavior on the right side. Where's the right side headed towards? -2. Good. All right, number 11, this is we're approaching 4 from the left. So here's 4. If you go from the left, where's it going? Can we put negative infinity? Why can we put that? One-sided, perfect. 4 from the right, positive infinity. And then 4 overall is does not exist. All right, this one is -5 from which side? From the left. All right, so -5 is right here. What value is being approached? Like, I'm just going to kind of match it up. What value is getting approached? We'll call that -2. Now, question, follow-up question on that one. Did it matter that it was from the left? For -5? No, because both sides were approaching the same thing, so it wouldn't have mattered. All right, and then this last one is 5. So we're going to find 5. What is being approached from both sides? 0. Does it matter that there's actually a hole there? Not at all. Now, these ones, remember, it's like following up the steps. These ones are not limits. This is back to algebra. This was calculus that we just did. Now we're back to algebra. This is there actually a point there? It's not behavior anymore. It's not like all touchy-feely. This is there actually a point there? So f of -2. Here's -2. Where's the actual filled in point for -2? 2, and we'll call that 2. All right, how about -6? There isn't one. Why not? There's an asymptote, vertical asymptote, so it does not exist. There's not actually a point there. All right, how about 1? F of 1. Oh, that's like the haha tricked you. The point's over here now. The actual point is at 4. Oh, but the limit is at -1. The limit goes to -1, but the actual point's up there at 4. All right, f of 5 does not exist. F of 4 also does not exist. F of 0 is -1, good, right there. And then f of -1 is what? 0. So do you get the difference between limits, which is a behavior, and actual values, which means like, is it actually there? Okay. All right, so guys, this is going to be just more practice with a different graph. You guys stay with me. This will go nice and quick. Okay. Limit as x approaches -infinity. That's just end behavior on the left side. So, hey guys, here's the left side arrow. Where's it going? Up. So we would put infinity. It's not leveling off anywhere. That arrow's pointing up. All right, limit as x goes to positive infinity. That's the right side. Now, do you see how I don't have anything dotted in there? So there is no asymptote. It's not leveling off. It's just going to keep on going down forever and ever. So we would put negative infinity. If there was a leveling off there, it would be dotted in. Okay. Limit as x goes to 0. Here's 0. You have to watch me point to it because there's no better explanation than, hey, look, I know that there's a hole there. It doesn't matter, though. If you zoom in, what's being approached from both sides? Yeah. -2 is your answer. Ooh, this one is sided. It's -4 from which side? The left. So here's -4. Watch. This is the left side. You can ignore all of this. We're just going to look at the left side. I know there's a hole there, but it doesn't matter. What y value is getting approached? 1 is your answer. Do I have the next one? -4 from the right? Good. -4 from the right. Here's -4 from the right side. You're approaching -1. And now look, if the left approaches 1, bless you, and the right approaches -1, what's the overall limit? Why is it does not exist? not approaching the same value. And what kind of discontinuity is that? Jump discontinuity, because it literally jumps. All right, here's -1 from the left. Look at, here's -1, there's an asymptote. We can get the answer though, because it's sided. Where does the left arrow go? Get down, so we would put -infinity, good. -1 from the right, positive infinity. And then -1 overall. Even if they both went the same way, this would still be does not exist. When it's not sided, you can't put positive or negative infinity. All right, and then last we're looking at 3 from the left, from the right, and overall. So 3 is right here from the left. So 3 from the left, what are we getting closer and closer to? -3, good. How about 3 from the right? What are we getting closer and closer to? -3, yeah, don't overthink it, it's -3. So what is 3 overall? -3, they match up, so that's your answer. If the left is -3 and the right is -3, the answer is -3. But is there actually a point there? No, this is like, haha, tricked you, the point is somewhere else. All right, but the limit is at -3. All right, these are not calculus, these are algebra. This is there actually a point there? So for -4, where is the actual point? -1, good. And then at -1, the actual point, oh, it does not exist. There's an asymptote. And then for 0, does not exist because there's a hole. And then for 3, it's actually at 2.